Until very recently a security researcher at Yahoo, fighting the bad guys, keeping them from getting in. A bunch of them built a badge, the Paranoids badge for DEFCON. Behind every successful badge, there's a trail of blood, sweat, and tears. And so here is the story of the making of the Paranoids badge. Please join me in welcoming to the Hackaday Supercon stage, R.
All right, thank you very much. Today, I'm going to be talking about how a group of Yahoos turned or in my case, former Yahoos, turned a vague idea into this, a DEFCON badge that actually exists. And by a small team, I'm referring to myself. We have Pinguino here in the audience, and other people who are not here. Couldn't have done it without you. I personally focused on mostly the electronics and the software, whereas Pinguino helped do some of the art. And some of my other former coworkers did things like logistics that were all really, really critical for making this actually happen. So the first thing is, okay, well, why do we want to make a DEFCON badge? Well, a bunch of us have just been vaguely having this idea for quite some time now. One person on our team said that it was a bad idea, so I wanted to prove him wrong. And I had never made a badge before, so I wanted to do it. We were all returning to, the company was returning to DEFCON in person after the pandemic, so we figured, okay, maybe it's a good idea, maybe it's a good time to go and do it. So around like January of this year, we finally committed to saying, okay, we're gonna make a badge. But, okay, now the first question, how do you justify a company like Yahoo making a DEFCON badge? Well, Yahoo's not really normally in the business of making hardware. Well, let's start with an easier question. How do you justify having a party at DEFCON? Well, fortunately, people who have come before me have solved that problem already. You justify it by saying things like, okay, well, DEFCON parties are good for team bonding, good for building morale, good for recruiting, good for getting your brand well known, and so on and so forth. So you have a perfect business justification for doing a DEFCON party, and a badge naturally fits within the same justifications as well. So all we needed to do was find a bit of money. And because there was this whole pandemic thing, we had plenty of conference swag budget. So a badge that would be given out would be swag. So now we have the budget. All right, so we're off to like a nice start. Of course, we have the usual constraints of, well, first we have like some minimum viable features that we want. We want a badge that's shaped like the Paranoids keyhole logo. And we want it to blink, but we also wanted like puzzles. We want everything under the sun, right? We want puzzles, challenges, peer-to-peer interaction, cheap, all the things. But we're doing this in a supply chain crisis, so we had to be a little bit realistic. And what we ended up with is something like this, where we have LEDs around the edge and LEDs behind the eyes. The LEDs can blink in different modes. And in the primary mode, which it is not in right now, in this primary mode, it is reactive to sound and music. So when you're at a party, the lights will flash in sync with the music. There are also scavenger hunt challenges that were happening at the DEFCON event where you could unlock the other patterns. The badges would also detect neighboring badges, and the eyes would get brighter the more neighboring badges there were. And so now I'm going to get into how we actually started building this, starting with the more artistic features. So the most visible aspect of a DEFCON badge is obviously the shape of the badge and the LEDs. So we wanted to make sure this looked really nice and perfect. So we wanted LEDs that were spaced out evenly, spaced from the side, and so on and so forth. So I started out by getting out some pencil and paper and doing high school trigonometry with sine and cosine. And then I realized, wait, we have computers for this. So the way I ended up doing the actual badge, the LED positions on the badge is I defined the keyhole shape in SoftSpace, which is an open source parametric mechanical CAD tool, not an electrical CAD tool. And the keyhole consists of a circle and some straight lines, so that's really easy to define geometrically. Inside the circle, I defined a number of points where each of the LEDs go, and then you can add constraints such as requiring these points to lie on a straight line, requiring them to be tangent to the circle, and so on and so forth. And you can see this is kind of a mess, but it made sense at the time. And once you have this, you can manually transfer the coordinates from this mechanical CAD tool into KiCad and have the LEDs be in the correct position. So if anyone is a KiCad developer, feature request. For the rest of the artwork, there is an open source tool on GitHub called SVG de Shenzhen, which is a plugin for Inkscape that converts Inkscape drawings into layers in KiCad. So if you can see on the back of this badge, we've got some nice pixel art that was drawn by Pinguino. That was simply a matter of converting it with the correct parameters. On the front, however, we wanted to have these backlit LEDs, where the LEDs are mounted on the back and are shining through the PCB as a diffuser. In order to do that, you need a cutout on the solder mask layer and also a cutout on the copper layer. Using SVG to Shenzhen, we could easily convert the cutout for the solder mask layer, but not for the copper cutout. So the workaround we used for that is if you define a dummy cutout, or if you define a dummy keep-out zone in the copper layer, you can open the KiCad module file in a text editor and manually copy the polygon coordinates from the solder mask layer to the keep-out layer. So if anybody works on SVG to Shenzhen, feature request. While we were doing all of this, we made a mechanical prototype to make sure that things looked good and made sure all the parts fit, made sure all the footprints were correct. And we did this because we were working on multiple things in parallel, and we hadn't actually designed the real electronics yet, but we wanted to make sure this was correct. So while this was like in the mail, we were working on the real electronics, which ended up looking like this. We ended up designing the badge around an NR52 SoC, RGB LEDs, and then all of the associated glue you would need to make something like this work. So how did we get to this as our final design? Well, we went through the usual brainstorming process. We went through options for wireless, and we listed the pros and cons. We went through the options for microcontrollers, and we also listed their pros and cons. We immediately realized if everything went to poop and we ran out of time, we could use an RP2040. We could get the minimum viable product of blinking, and that was our backup plan. But we, of course, wanted to do something much more sophisticated. So here's the point where we got saved by luck. Early at the beginning of this year, while we were doing this brainstorming process, I was browsing through distributors and found that one distributor had this layered BL653 BLE module in stock. Not in very large quantities, but in sufficient quantities to build the number of badges we needed. So this module contains an NR52833, which is the same chip found in, I believe, the BBC microbit. It can do BLE and a bunch of other wireless protocols, so badges can talk to each other. It's sufficiently powerful that you can run the entire firmware on it, so you don't need any other control chips. It has all of the usual microcontrollers peripherals. And what we ended up doing is once we chose this, we ended up designing the rest of the badge features around this chip in particular to take maximal advantage of this chip. So this chip has a PDM I2S interface for handling microphones, which is how we decided, okay, we're going to commit to the feature of having it reactive to sound. It also had NFCs, so we could implement a feature where, as you were solving a scavenger hunt at a DEFCON party, you could go to a station and win a prize by scanning your badge. The badge will report which challenges you've solved. But because there's a supply chain crisis, we really wanted to lock down and made sure we actually had all of the critical parts, before we actually move on. So here's where we hit our first snag. We're doing this at Yahoo, and Yahoo is a large company, and for those of you who have worked at large companies, you might know that you can't just go to a distributor and hit add to cart and buy something. That's not how it works. You have to go through a vendor approval process, and then you have to go through a bunch of bureaucracy to buy parts. So fortunately, as always, there are workarounds for this. We had a company that provides some kind of business services that specializes in doing these one-off purchases. And apparently they owed Yahoo money for some previous transaction. I don't know. I didn't handle that part. But we had to tell this company to go to the distributor and place an order at the distributor and hope the parts showed up. And as you can probably guess from the way I'm describing it, this process took a while. And by the time the order was placed at the distributor, it had gone out of stock. But the distributor gave us a lead time that was just early enough that we would have no chance to recover if anything went wrong. But we decided, okay, we really want all these features that we designed around this module. Let's go for it. And a few weeks later, way earlier than expected, the parts showed up on my doorstep because somebody at the distributor couldn't do inventory. So we got super lucky. Okay, the next thing we needed to lock down was the LEDs, because the LEDs are also a really critical component that's hard to substitute, same with the microcontroller. We ended up choosing the SK9822 LEDs, which are called dot star in Adafruit's terminology. And here's where we hit the next snag. The most cost-effective way to get SK9822s in the quantities we needed, which is not a huge quantity only, but also not a small quantity, is to buy them off AliExpress. So at this point, one of my former coworkers who knew how to talk to the right people in the right places basically went to internal procurement and said, hey, look what happened with the BLE modules. Can we not do that again? And somehow procurement said, okay, yes, we can just not do that again. So this ended up with a Google Meet call where one person very carefully went on AliExpress, selected the LEDs we needed, and very carefully put in their Corp Amex into AliExpress while other people were watching to make sure no mistakes happened. One gotcha we ran into that fortunately I caught before even doing the mechanical prototype is that the KiCad built-in library footprint for the APA 102 is not correct for the SK9822. The pin ordering is different. Fortunately, this was caught, as I said, before we did the prototype. So after we locked down the blinky LEDs around the edge, we needed to lock down the LEDs that we were using for backlighting the eyes. So I just went on DigiKey's parametric search. I found this part. There's tons of them available, so we didn't have to preemptively order them. But here's where we hit the next gotcha. So this mechanical drawing comes from the datasheet for this part. And if you look at it, you'll notice pin 1 is on the right-hand side and not on the left-hand side as usual. In addition, this is the top view as the part is placed on the carrier tape. But because this is a reverse mount LED, this is the side the light does not come out of. So after screwing this up, which we didn't catch, but we caught on the mechanical prototype, we could move on to the actual board. Oh, by the way, here's the mechanical prototype attached to a dev kit. This is how we were prototyping things in parallel. So once we had locked down the really critical parts, we realized, okay, time to lock down the rest of the miscellaneous stuff. Has anybody here tried to buy a boost converter during the component shortage? Well, that's also fun, right? So I was browsing DigiKey's parametric search again, and I found this chip, which basically requires no external components except an inductor or capacitor. It has fixed 5-volt output, which is the right voltage for running the LEDs. Is designed for battery-powered devices. It's basically perfect, except it cannot output enough current to power all of the LEDs at full brightness. So, well, how much current can we actually get? Well, the data sheet has an example for 500 supposedly, but I went and simulated a bunch of circuits with SPICE and could never get more than about 350, which if you work through the math turns out to be about maximum 5 milliamps per LED color channel, which turns out that's actually quite bright. This is actually using even less than that. It turns out when you're at dark party venues in Vegas, you don't need LEDs that are blindingly bright. And also, we're running off of AAA batteries, so we have limited battery life anyways. So we said, okay, that looks fine, maybe. Let's just build it. Let's hope it works. Worst case, we'll fix it in software and limit the brightness. And it turns out that we didn't actually have to add too many fixes, but this is the source of one of the major bugs on this badge, which is if you are drawing a lot of power from the LEDs, but the batteries are running low, the boost converter will keep drawing more power from the batteries, and the battery voltage will start dipping more, and it will cause the NRF52 to brown out because the NRF52 requires a much higher voltage than this boost converter. And once it does, the NR52 will crash, but the boost converter will still keep the LEDs powered on. And in hindsight, we should have added a proper system of undervoltage lockouts and resetting to take this into account, but badge life, we're always kind of in a hurry. We need a level shifter to interface between the NRF52 and the LEDs. This is a really standard part, 7.4, blah, blah, blah. The only gotcha here is, well, we didn't know which part we would actually be able to get. There are parts available in small quantities over time. So what I ended up doing is I compared all of the mechanical drawings for all of the different packages that TI had this part in and made hybrid footprints that could fit basically all of the packages, several hybrid footprints, and connected them all together. So whichever one we could buy, we could use it. Okay, so now time for the really miscellaneous stuff. We needed a MEMS microphone, but those are found in all sorts of consumer electronic devices. You probably have like several MEMS microphones on your person just right now. So the supply chain for this is really easy. The only gotcha here is that we started with this part over here, which I believe Adafruit carries on a breakout board, that is I2S. But the NRF52 I2S peripheral doesn't handle 24 or 32-bit microphones due to hardware limitations. So we discovered that while building this prototype. So we quickly switched it to a similar microphone with the same package, but similar series, but it uses a PDM interface instead. And that one works. All right, time to write software. Software is actually quite straightforward because we just used the Nordic NRF Connect SDK. It's full of examples of how to use each of the peripherals. So you just take each example, copy the parts you need, and then implement the functionality of our badge specifically. One gotcha is that we wanted the LEDs to have really nice colors, some of which we wanted to match, for example, internal brand guidelines. If you pick an RGB color on your computer and just use that as the raw brightness for LEDs, that doesn't look right because colors on your computer are typically stored in the sRGB color space, and you need to apply this gamma correction function, which you can look up like on the internet, to convert them to linear before you can feed them into your LEDs. So we did that. Most of the colors look great. Purple didn't quite look great, but Yahoo's brand color is purple, so a bunch of us spent some time on a call carefully tweaking it until Pinguino said it was okay, and then we went with that. We added a production test mode so that at the factory they could test all the basic functionality so that we didn't have to test badges in a hotel room in Vegas. One thing I regret not doing that we should have done in retrospect is we should have added a bootloader for installing updates because I wanted people to be able to hack on this badge. But right now, to be able to do that, you need to use SWD because there's no USB bootloader, which is somewhat unfortunate. All right, so now the design is mostly working. How do we get it manufactured? Well, one of my former coworkers is well known for making certain malicious USB cables. And a local, well, not local, an American manufacturing company, a small business called Cyber City Circuits, reached out to him on Twitter because of it. And we ended up talking, and we mentioned to Cyber City, oh, we want to build a DEFCON badge. And Cyber City said, oh, that sounds fun. Let's help you with that. And Cyber City is an American small business. They're set up to do business with the federal government, and they have registration for ITAR and all of these other things, which means they understand how to do American bureaucracy, which meant that it was really, really easy, well, relatively really easy, Pinguino's laughing at me, to get them onboarded as a vendor. They agreed to help us source production quantities of all of the parts we didn't lock down ourselves, namely the LEDs and the microcontrollers. And because we started working with them really, really early, I think in March or something, well before the design was finalized, we had a mutual two-way communication of, oh, this will make things easier for them, easier for us. Highly recommended manufacturer, was great working with them. The only issue we did run into was a small yield issue, where after they made the first 2 assembly samples, they tested it with the self-test program I mentioned earlier, and they were fine in the factory, but by the time they got to me, one of them was working, one of them wasn't. It turned out what happened was, as they were applying solder paste with a squeegee, this flexes the board a little bit, and there was a part of it where you could get slightly more solder paste on one side of an LED than the other, which would make this joint unreliable. So basically, I was fidgeting with the one that worked. I noticed that this LED was crooked. I sent them this photo, and cybersecurity said, "Oh, great, we figured out the problem. Thanks, we've never had this problem before." Another thing is we needed a pogo pin jig to program badges. So not only was this the first time I had built a DEFCON badge, this is the first time I built a pogo pin jig as well. So I built this thing over here, which works for me because it works once if you're really careful. But as you try using it for more and more boards, this starts getting unreliable because there's no way to align it or anchor it. Fortunately, one of the engineers at Cybersecurity Circuits looked at our really nice assembly diagram here and said, "Oh, that's really easy. I'm pretty sure we can 3D print a jig for you that has pogo pins." And they did. So now we're in the home stretch. Boards are being manufactured. We are about a month out from DEFCON. Time to finish the rest of the miscellaneous stuff. So someone on my team wrote an app that scans the NFC, just usual app. And my other coworkers handled things such as having a really nice printed manual, ordering lanyards that do not contain metal if you were at the talk yesterday, and getting batteries, ESD bags, putting things together, and all of the final logistics. And we made it. We didn't even have, we had only a little bit of minor last-minute crunch. And that's it. Is there time for questions? Yes. Okay, does anyone have a question? How many did we make? We made 250 because we could justify giving it out internally to internal people. We couldn't justify giving it out to everyone who stopped by. But something I did forget to mention, now that you mention it, is the design for this is open source. You can get it on GitHub. I forgot to put the link in here, but it is on github.com/theparanoids/keyhole-badge if you want to make your own. Anybody in the back? Sorry, I can't hear you. Oh, how we convince